Okay, I'm recording this in case anybody else needs to hear it at another time. So polygons are 2D objects. And by definition, polygon means a many-sided figure. I believe poly is a base in Greek. It's a Greek base for many. And then gon, I think, is a shape or a figure or something like that. I'm not really a linguist, so I don't quite know, but we've done polynomials before, and those are many object expressions, etc. So poly is a word we've heard before, and polygons refer to shapes, and we have special names for polygons with 3 sides up to 12 sides. I'm just going to run through them briefly and talk about ones that are important or ones that we tend to mess up. So 3 sides is triangle, we know that. 4 is quadrilateral. Sometimes we want to call it a square or a rectangle, but we're ignoring a whole bunch of other quadrilaterals, rhombuses, parallelograms, kites, trapezoids. So we don't want to just call it that. We want to use the whole general quadrilateral. 5 is pentagon, 6 is hexagon. 7 is one we often mess up on. It is heptagon. It's not septagon. A lot of us want to write septagon. It's not it. It's not the right base, not the right root, etc. Heptagon. Somebody misses that on every test, final, whatever. It's on a bunch of stuff. Remember heptagon. 8 is octagon, 9 is nonagon, 10 is decagon. Where it gets weird is 11 is a hendecagon. I don't know why. And 12 is a dodecagon. Once we get past 12, though, we just call it a that number gone. So if I have a 15-sided figure, it's just called a 15agon. Or 15gon. I like 15agon better, but it doesn't really matter. If it's a 27-sided figure, it's a 27agon. If it's a 159-sided figure, it's a 159agon. Nothing crazy, just throw agon at the end of it. All right, my handwriting's trash there. I'll try and fix it as we keep going. And I was making fun of you, Gavin. What was I thinking? Talking a lot of trash. All right, polygon with n sides is anything more than 12. We just said is an n-gon, so remember that. I gave the example of 50, and then I also gave 3 other examples off to the side. Now, polygons are not just important by the number of sides they have. It also is important on what kind of shape they are. We have a convex polygon, which means that everything is pushed out. I don't think that's an awesome definition, so I like to think about concave. Concave means that something is caved in. It's like if I took my finger and like poked into the polygon and it now has like an indent in the polygon. In the concave example, it's like I poked right there. There's a little indent right here. The real like math definition is if I was to extend the sides into lines, then part of the line would be on the interior of the shape. You see if I extend that line, some of it's inside here in the blue, that's a problem. That makes it concave. On the other side, convex, if I were to extend the lines, nothing weird happens. It is all on the outside, nothing is in my blue shape. Convex is just a normal polygon. Most of the shapes you've ever dealt with are convex. Okay? I want you to try 1, 2, 3, and 4 and tell me, is it a polygon or is it not? And then I want you to try 5, 6, and 7, name the polygon, and then tell me if it's concave or convex. Okay? I'm going to take attendance. So in the 10 seconds it takes me to attendance, I want you to try these. 1, 2, 3, 4, is it a polygon or no? 5, 6, 7, is it, what's its name, and is it concave or convex? Is it concave or convex? Okay. Like 3 more seconds. 3, 2, 1. All right, bring it back. I don't care where you're at, bring it back. Number 1, do we think polygon or no? Yes. Any reason why? It has sides, right? It looks like it has sides. What about number 2? No, why not? It's a circle. There's technically no sides on a circle. All right, what about 3? Why not, Allie?
It's 3D.
It's 3D. Each side of the 3D figure is a polygon, but as a whole, it's 3D, so it's not. I can't be 3D. And then last one, polygon or not? Yep. Okay. Yep. We're all good. Mm-hmm. That's it, though.
Okay.
I'm just kidding.
For number 4, would that be a concave?
It would be concave because it's kind of caved in right there. It looks kind of like 2 polygons all together, but at the end of the day, it's a shape with sides. So it's a many-sided shape and counts as a polygon. Mm-hmm. All right. What about number 5? I think identifying concave or convex first is easiest. Is this one concave or convex? Why? I can literally draw an arrow in, and that's sometimes my reasoning. I just draw this little arrow, and I'm like, because I can do that, that's why it's a concave. Concave? And then what would I name this shape? Good, an octagon. No, don't think that you're too cool for school and then don't count the sides, or I physically draw on them so I know if I counted them. We get to like the final or like chapter 1 test, and sometimes people write a nonagon instead of an octagon because they thought they were too cool to like write on their picture. Literally, I'm the only one that sees your test. Write on your picture. I don't care if you write the dumbest thing on there. I'd rather you do that and not mess up something easy like an octagon, right? Okay, next one, concave or convex? Convex. Good, because it's normal. There's no indent in. And then what do I name this shape? Nonagon. Good. And then the last one, is that one concave or convex? Concave. And what do I name it? Doesn't really look like pentagons we're used to seeing, but it has 5 sides. It's a concave pentagon. Okay. I'm not going to write anything with the box below this, but I just want to talk through it. Those are formulas that you should know or should have seen before. Maybe you don't remember them, but you're like, oh yeah, that's the perimeter, that's the area, blah, blah, blah. I want to just put it there as a reference. So if we need to reference back, most of the problems we're doing from now on are perimeter or area or circumference. So I want us to be able to look at this picture. Okay? Awesome. Let's zoom to the back side. All right, we're just gonna keep doing some problems, practice this kind of stuff, see if we can get all sorts of examples under our belts before we go home. This says find the perimeter and the area of each figure, label your answer with the correct units. That is huge. Label, 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 label. So let's do the first one together. Perimeter, if I don't remember, it's just adding up all the sides. I'm gonna go back above and I'm gonna look at perimeter of my rectangle. I personally like to do 2 times L plus W. But you can do anything. You can do 14 plus 3 plus 14 plus 3. You can do 2 14 plus 2 3, whatever makes you happy. I'm going to do it like this. 14 plus 3 is 17. 2 times 17 is 34. I'm going to do just inches. If it's perimeter, it's just the units, no exponent, no nothing. Next, I'm going to do area, which is length times width. Ooh, 42 maybe? And area is always in inches squared, or sorry, units squared. And in this case, my unit is inches. Okay, everyone doing good? All right, next one's a square, so I'm gonna do that one. I know it's a square because of all my congruent marks. That's congruent, that's congruent, that's congruent, that's congruent. What's a good way to write my perimeter for this? Well, like how would I set it up? 4 times 16, that's a really good way to do it. 4 times 16. But I would get 64. Everyone's like, the answer, duh. That would be 64 millimeters. And then for area, we just have to do length times width, or since it's a square, I can do the side length squared. I'm gonna do 16 squared, which is 256 millimeters squared. Everyone hanging in so far? Awesome. The next one, it says length equals 3 feet and width equals 8 inches. Ooh, feet and inches, what? Can I just do 3 times 8 and call it a day? Maggie, what do I need to do? Awesome. I have to convert one way or the other. Personally, I would much rather have like a large number of inches than have like a decimal of feet. I don't want 8 inches to be like point whatever of a foot. I would rather 3 feet become inches. How many inches are there in a foot? 12. Now, I don't know how you guys have learned units in the past, but when I was in chemistry, we were kind of taught this like grid way of writing it so that my units are always across from each other. And that's how you know whether I'm multiplying by 12 or dividing by 12. So my feet cross out and I'm left with inches. And so I do 3 times 12, which gives me 36 inches. It may seem silly for something like this where you're like, I know that I just multiply by 12. But if you do more, then it becomes a little bit more challenging. So I'm gonna write 36. All right, now do area and perimeter. See if you can do it on your own while I'm working on it. Maddie, do you want paper notes? Perfect. All right, 36 plus 8 times 2 is 44 times 2, which is 88. What did I just say? 36 plus 8. 2 times 44 is 88. And then area is going to be 36 times 8, which is 288, I think. What is my units on here? Inches. I had kids ask me last period if I had to change it to feet. You can, but I just find that that can cause some mistakes. So unless I ask for feet, I would just leave it in inches. Just make sure your unit matches whatever you want it to be. So if I want it to be inches, I need my unit to also be inches. All right, feeling good so far? All right, now we've got 2 word problems that go with this. The first one, Mrs. Henderson wants to put a wallpaper border around her living room. The room is 18 by 22. How many feet of border are needed? All right, time out. Do I want to do area or perimeter? Perimeter. I hear an area, I hear a perimeter. I hear one of each. Who wants to argue one way or the other? Allie, why argue your perimeter?
She puts it around her room, like on the walls.
Okay, Allie's saying around, that's defending her perimeter. Anybody else defend with Allie or bring up area again? Nope. Okay. I'm going to say yes. I'm going to argue the keyword is actually border. Do any of you, ooh, that was a mess. Do any of you know what a wallpaper border is? Because wallpaper, you're like, oh, it's just a whole wall, right? Gavin, that's what you were thinking. It's a whole wall. A wallpaper border is like a foot long, and it goes just like around the top of the room. It's like this little thing at the bottom of my floor, but if it was like at the ceiling. It was like really big back in like the 80s and 90s. Like when I was little, we had like a border in my bedroom, and my mom put one up in the living room. It's like flowers or like cartoon drawings or something like that. Have any of you seen that? Like, does your grandma have that? Maybe. Okay. So I'm realizing this problem's getting a little outdated. So I'm going to have to rewrite it for next year because we don't know what a border is. But if I said I was going to put a border of bricks around my garden, you would know it's going around the edge of the garden. It's not going to go over where all the plants are, or else then it wouldn't be a garden, right? So border is your key word to mean it's talking about perimeter. Okay. The room is 18 by 22, so I'm going to do perimeter around the outside, and I'm just going to do 2 times 18 plus 22. The reason we spent so much time talking about what it was as opposed to just solving it is because I want you to be able to use those words and use that thought process when you face a problem like this in the future. I'm going to do 2 times 40, I think, and then 2 times 40 is 80, which is 80 feet squared is how much perimeter we'll need. Okay. Next one's another word problem. It says a restaurant owner wants to put a cement patio behind his restaurant so people can eat outside. Wow, that's very COVID relevant. Gavin? Oh, that was dumb, wasn't it? Thank you. Good catch, Gavin. All right, feet. Wow, that was silly. Don't make silly mistakes like that. That's why I make mistakes so you don't have to make them. All right, people are eating outside. Again, I said COVID relevant. That's kind of funny. The patio will be 16 feet wide and 25 yards long. What will the area of the patio be? Time out. Am I solving for perimeter or area? I hear area, I hear perimeter. Cement patio. Area? Maddie, you want to argue area? Why do you argue area? It does. This one just said, what will the area be? So I'm just going to know, okay, it said, what will the area be? I'm just going to solve for area. Okay. I've got my shape. I've got my, oh no. Okay. My iPad was doing weird things last period, so I hope it doesn't do that for you too. All right, so I've got 25 yards. I have 16 feet. Do I just do 25 times 16 and call it a day? What do I have to do, Sterling? Good, I have to change my yards to feet. What do I need to multiply 25 by to get feet? 3. So 3 times 25 is 75 feet. So now I have feet and feet. So I'm going to do 16 times 75. If I remember from my last 2 classes, I think that's 1,200. Someone want to confirm me? Perfect. I need my mental math check sometimes. I sometimes forget. And then this one is squared. Is this in feet or is this in yards? Feet. Good. Stay consistent. Again, you can change it back, but we have to stay consistent. Any questions on the area and perimeter of like the square rectangle types of problems? All right, let's do the circle ones. I've got circumference and area. If I don't remember, I'm going to just jump back up here. I personally remember circumference is 2 pi r. I can't remember pi d for whatever reason. And then area is pi r squared. So 2 pi r squared. I come down here. The only thing I want to point out is your answer should be in terms of pi. You should have a pi written in all these answers. I do not want you to go to your calculator and type 3.14 or hit the pi button. Honestly, it's just easier this way. It's harder to go back and put it into the calculator, and it's just more exact. And so in geometry, I want us to be as exact as possible. Pi, as the actual symbol written out, is the most exact. So I have 8 centimeters. That's my diameter, which means that my radius must be 4. So circumference is going to be 2 pi 4, which is 8 pi. And then area is going to be pi 4 squared, which is 16 pi. Ooh. Again, I want you to show me your work on this. I know it's pretty simple work, but you should at least show me the plug-in steps. Because if you just write one answer or another, I don't know what you did to get it. And you might have done circumference instead of area when I asked for area, and then I'm able to see why you got something wrong. So show me all of your steps. Next problem is the exact same, but this time it just said my radius was 9. Circumference equals 2 pi 9. Area equals pi 9 squared. 2 times pi times 9 is 18 pi. Pi times 9 squared is 81 pi. I know I'm moving, but are we doing okay? Okay, the next part, it says we're going to find the area of the shaded region. All angles are right angles. How do I find the area of that shaded region? Do you have any ideas? Maddie? Awesome. Maddie says we're finding the big area, the area of the entire shape, and then we're going to minus out this little square right here. You can write it separately. You can do 18 times 12 and then 4 times 3 and then put them together. I'm going to do it all together, though. I'm going to do 18 times 12 minus 4 times 3 all in the same equation. It's essentially the area of the big shape minus the area of the little shape. 18 times 12, I believe, is 216. 4 times 3, I know, is 12. 216 minus 12 is 204. Is this going to be centimeters or centimeters squared? Squared, very good. We doing okay? Am I moving too fast? No, we're at a good pace. Okay. 16 is very similar. Yes, Maddie? Awesome question. When we use area, area is always squared. Perimeter is never squared. And then if we go farther, volume is always cubed. So those are just kind of rules of thumb. It's been a long day, guys. Has your day been long? You guys are killing it in geometry class. But I just am tired. Okay, we got a couple more we got to get through, though. Number 16, there's several ways I can look at this. What's one way that you looked at this? Maggie? Good. How did you divide it into shapes?
I made from the 3
Mm-hmm.
to the other 3, I cut it down.
Like this?
Yeah.
So you did like vertical lines?
Yeah.
Mm-hmm. Maggie did vertical lines. Yep, that's exactly a great way to start. Did anyone cut it up differently? Someone in my last class was like, let's do horizontal lines. So we did this way. That's still three shapes you can do. Somebody in my first class today was like, well, I could take the whole shape and then minus off these little white parts right there. That's also okay. Lots of ways to do it. I'm going to do it like Maggie said to begin with. I'm going to do split it up vertically and find those 3 shapes and add them together. What we're doing here is we're essentially adding parts. We're doing part plus part plus part. And the other one, we took the whole and we minus out a part. There's a lot of ways you can think through this. So don't be afraid to try something new, or don't be afraid just because like I said something or Maggie said something doesn't mean yours is right. I'm not going to say it's always right, but I'm going to say there are lots of ways to do it. So be creative. And if something came to you first, go ahead and use that. All right. So this shape, this first shape is It's 6 across, and it's 3 and 3 and 3 long, so it's 9. So I've got 9 times 6. The middle one is 6 across, and it's 3 and 3, which makes it 6. So 6 times 6. And then this little shape is 3 and 6, because I know this was 6, that was 6, so this has to be 6. I really rushed through that. Do I need to explain that better? Yeah. So I have it broken up. I know that like this distance right here is 3. And then this distance right here is also 3. So then this whole length right here is 6. If this is 6 and then this part's 3, then together they're 9. So it's 9 tall and then it's 6 across. So that's where I got my 6 by 9 to begin with. I'm kind of using this to carry through as I go. So then the middle shape was a 6 across, and then we already decided it was a 6 up and down. So that's where I got my 6 by 6. And then the last shape, it doesn't say 6 anywhere. You're probably like, oh yeah, I'm cool with this 3 right here, but how'd you get the 6? If the whole bottom was 18 and this is 6 and this is 6, I can just minus 6, and I'm left with 6 is what had to be left right here. 18 is 6 plus 6 plus 6. Yes or no? No, don't lie to me, Charlie. So no. If this is 6, then I can assume this side's 6. We're good with that? If this is 6, then I assume this side is 6. So I've taken up 12 of it. If that's 12, but the whole distance is supposed to be 18, then that means 18 minus 12. My last part is 6. Okay. If you're still lying to me, we'll find out later. You're not? Okay, good. All right, now I multiply 9 times 6 is 54, 6 times 6 is 36, and 3 times 6 is 18. Add them up. 54 plus 36 is 90, plus 18 is 108, I think. 108 meters squared. Okay. We're actually going to skip this one right here because I think there's one with the vertices like it on your homework. If not, this is at least kind of reviewing a little bit of what we did yesterday, so I want to review that. So flip over to the last side or the last question you see on your notability notes, and this is coordinate geometry, so that means I'm on a coordinate plane. I need to find the perimeter and area of triangle PQR with these vertices. P is at -1, 3. Q is at -3, -1. R is at 4, -1. Oh, and that's it. I don't know why my intonation actually looks like there was more points. That's it. Connect your dots. We now have a triangle, and we want to find the perimeter and area of it. If I want to find the perimeter, I need to find the distance. I need to find the length of each of those, which means I have to do distance formula. Now, let's work smarter, not harder. I do not have to do distance formula for this one. Do you know why? I'm just going to count the boxes. If it's straight up and down or straight horizontal, just count the boxes. Don't make more work for yourself, because also that gives you the opportunity to mess up, and we want as least amount of opportunities to mess up as possible. 1, 2, 3, 4, 5, 6, 7. That is 7. Okay, so I already know QR. That was easy. Okay, now I need to find PR and PQ though. So let's do that. PQ, to find this distance, I'm going to use the points P and Q. Let's label them X1, Y1. Let's label them X2, Y2. I'm going to plug into my distance formula. So if we don't remember, we can use our notes from yesterday. If not, I'm going to write it PQ. Square root of x2 minus x1, -3 minus -1 squared, plus y2 minus y1, -1 minus 3 squared. Minus a negative becomes plus a positive. Negative 3 plus 1 is negative 2 squared. Negative 1 minus 3 is negative 4 squared. Negative 2 squared minus 4, negative 2 squared is 4. Negative 4 squared is 16. And then 4 plus 16 is 20. I do have to check if 20 can be simplified though, so let me do that. And I'm doing my little factor tree off to the side. 20 is 2 and 10, and 10 is 2 and 5. Oh, I do have a match right here with my 2's. 2 radical 5. That's my distance. So PQ's distance is 2 radical 5. We're going to have to find PR on Wednesday. I think that's the next time I see you. We have to find one more distance in order to find the whole perimeter. We can't just add up 2 sides and call it a day, and then we'll find area. But I think this gives you a really good amount of problems to do for homework, or problems to look at while you do homework, okay? Just a reminder, homework it's another textbook-like problems. I'm just showing it to you on C period, even though I know you're D period. I will put down, I haven't updated it yet, so I'll update it right after school. These are the problems. I'll tell you which ones to do. You won't have to do all of them. And that will be due on Wednesday. On Wednesday, because I don't see you guys on Tuesday, right? Remember that Monday is Labor Day, so we don't have anything. Like, you don't have Mission Monday. We don't have Zooms or anything. Like, this is actually supposed to be an off day. So this is a vacation day. It's a holiday. You don't have Zooms. And then Tuesday is a real day of school in person. And next week is funny. It's like a day 6 is on Tuesday, day 7 is Wednesday, and then Thursday and Friday we're splitting day 1. So I think we have Alpha A, B on Thursday, and then C, D, and E on Friday. And in between those times, we're doing other activities. Like, we're going to have math. We're going to do a service activity. I don't remember what we do with D period, but we do something together. I don't remember what it is. Maybe we go to mass. I think we go to church. We go to mass together, which should be on the football field. And last time I looked at the weather, it should be nice. Like, it was like 71 degrees, so that's not too hot or anything. I think that's it.
Let us pause for prayer. Lord,